Oh, hey, this is the battery control center for my RV. This is a 2007 Four Winds Hurricane, and I was having some issues with my rear view mirrors. They have they're motorized so that I can adjust them while I'm driving, and the dashboard fans, they would intermittently shut off and not work while I was driving down the road. And I believe the problem's in here. And the reason I say that is because there are some fuses. I'll open this up later. There's some fuses back in here that really hard to get to when this is installed in the unit, but I was able to get in there and like wiggle this 1 amp fuse that controls the mirrors, and the mirrors would intermittently start and stop. So I'm sure the problem's in here. So I'm pulling this out. I'm going to give this a once over and see if I can improve on the reliability. It's a bear to get out of there. Oh, I said it's a bear to get out of there. These two screws that hold this back end in are like back here, and I was thinking about taking the headlight out to maybe make it easier to access these, but these are blind access. You kind of have to be a contortionist to get your hands in there and get the bolts out. I was able to do it. And there's one on this side here that comes out, so it's held in by three points. And then you have to remove your the connection for the coach battery and the chassis battery right here, coach and chassis. You have to remove the switched chassis connection, ground wire here, and then the feed to the house panel has to come off. And before you remove any of these, you should disconnect the cables at the chassis battery location, and then disconnect them at the coach battery connection as well. And that way it just prevents any accidents from happening, like short circuiting from 12 volts to ground. And also, when you're disconnecting your batteries, always remember to disconnect the negative side first. That way, if you make a mistake when you're taking the positive side off and you accidentally short positive to chassis or something like that, you won't get any arcing from that event. All right, let's see what we have inside. So I read in one of the RV forums that prior to 2007, Thor had issued a recall on 2007 Hurricanes and various models of motorhomes that had the RV Custom Products Battery Control Center. And the reason they had the recall was because there were reports that there was a possibility that you could lose the chassis battery power while you're driving down the road, which would be a pretty nasty thing to have happen, because you would basically, your engine would die, your lights would turn off, you would probably lose braking assist. I'm not exactly sure of all the details. I just know it didn't sound like a good thing. So I got kind of curious to know if my RV fell into that. I have a 2007 Hurricane, and I went through all the documentation that came with it, and I couldn't find anything stating that there was ever a recall for mine. And so I decided, since I was having issues with a couple of the fuses in here, I might as well pull this thing apart and just check it over to see exactly how it's built on the inside, and try to decide whether or not this one is in that same category as being defective. So one of the first things I noticed is that this is a Rebbe board, and I was able to get some documentation from RV Products, RV Custom Products, that stated that the Rebbe board contained a new circuit to basically lock out the ignition switch. The way it works is when your ignition switch is turned on, there's a relay that prevents the chassis battery switch located inside the door of the RV from throwing the latching solenoid for the chassis battery into the disengaged side. So in other words, there's a lockout in here that keeps you from disengaging the chassis battery when the ignition is turned on. that's a good sign. So I believe that that's what the initial problem was. You could be driving down the road, somebody might get up and pop that little switch there, which would disengage your chassis battery while you're driving, and you'd lose everything. So the Rev-B boards, I believe, have fixed the problem. Is my lighting going wacky over here? Is something going on? You know what I need to do? I need to do something like this and say, okay, let's lock that. There we go. Let's lock that. Now, hopefully that lighting won't bounce around a whole lot. I'll probably look like a ghost, but I'll look like a ghost all the time. So anyway, so let me show you what's inside here. Give you a clue. Bring you guys over here a little bit. I'm going to point you down in this direction. How's that? Can you see a little bit here? So, and I'll it's basically oriented properly for you. Okay. So what we have here, this is the Rev-B circuit board. Beneath this board are 3 solenoids. There's a solenoid back here in this corner here. It is not latching. This is the battery interconnect solenoid. It actually ties the buses of the chassis battery and the coach battery together in order to provide charging when you're driving down the road. Your coach battery, the house battery, can actually be charged by the alternator as you're driving, and this is managed by this interconnect solenoid. It's also provided as a way to provide sort of an assisted start. Let's say that your coach battery, or I'm sorry, your chassis battery, which controls your engine, your ignition system, let's say that dies for some reason, you can So as I was saying, if your chassis battery should happen to die and you need assistance getting it started, you can push the auxiliary start button on your dashboard, and that will engage this particular solenoid and tie the 2 battery buses together to allow your chassis battery to be assisted by the coach battery for starting your engine. Period. That's it. And I feel like my phone is stopping and starting on me, but maybe not. I'm hearing little beeps. So, and then beneath here are 2 other solenoids. There's a solenoid for the chassis battery. That's the chassis battery disconnect solenoid. And the one down here is the coach battery disconnect. And these particular bolts, all these screw points that you see here, are actually electrical connections to those solenoids. Okay. I should mention that the chassis disconnect solenoid and the coach disconnect solenoid are both magnetic latching solenoids. What that means is they don't draw power when they're engaged, and they do not draw power when they're disengaged. You apply 12 volts one time momentarily in one direction, in one polarity. For instance, if I put positive here and negative here, or ground here, it will engage the solenoid, and when I remove that voltage, the solenoid will stay engaged. The only way it will become disengaged is if I reverse the polarity, put positive down here and ground up here. It will pull the solenoid in the opposite direction and disengage it, and it will be latched on that disengaged position. And the advantage of that is that there's no drain on your battery when you're parked. You know, if you're boondocking, you're dry docking, and you have your house battery solenoid engaged, it's not requiring current from the battery to hold that solenoid in that position. So that's why they call them, or you know, make them a latching solenoid, mechanically latching or magnetic latching solenoid. Anyway, they're underneath this board. So I'm going to take this board out in a minute. But if you also notice here, there are 4 different relays on the top side of this board. This particular relay here is for the fog lights. This controls the the current needed to run fog lights on your system if you have fog lights. I don't have fog lights on my system. This is the ignition solenoid. When you turn the key, this relay engages and connects chassis power to fuses here that are required to run your motorhome and some other various things as well. This relay is the accessory power relay. So when your key is in the on position or the accessory position, this is also engaged, and it provides power, chassis power to accessory fuses down here. There's some larger 5-amp fuses here. These are automatic resetting fuses. Once they trip, after they cool off, they'll actually reset. You don't have to replace those. All these others are, once they're blown, you have to replace them. There's another interesting fuse down here. It's a circuit breaker. It's a resettable. There's a reset button right on this side of it. Can you see that? Right there. And this goes out and feeds the house panel. Still working on exactly where this feed goes. I'm thinking it might go back to my my converter, but not 100% sure on that. But what happens here, if you replace your house battery, 9 times out of 10, and maybe 10 times out of 10, this breaker will trip, so that when you're done replacing your battery, nothing's going to work, and you're going to wonder what the heck is wrong. What happens is this circuit breaker trips, and you have to come in here and physically push this button back in after you replace your battery, and that will restore power to your coach. Okay. There's nothing in the documentation that really calls that out. That's something I learned online in some of the forums. Now the bottom fuse, this one right down here at the bottom is a 1-amp fuse. It's F15. That is for my power mirrors. Right above it is a 5-amp fuse. And I believe it's called out here on the cover. The 5-amp fuse F13. It's on P5. F13. Okay, that's Jack's power. The mirrors is F15, so these are my jacks, my leveling jacks. F12 is the mirror heaters. F11 are my dash fans. This fuse right here, this 10-amp, was also loose, and I believe it was causing my dash fans to drop out. Okay, so let me show you exactly what I did to try to improve the reliability of this box. On every fuse, every one of these blade fuses, I pulled them out and took a pair of pliers. I'm going to try using a little bit longer set of needle nose pliers. Came in here and just squeezed these together on both sides. The goal being here to try to make a bit of a tighter grip on this fuse. Then reinstall the fuse like that. I did that for every one of the fuses on this board. The second thing I did is all of these connectors have these bifurcated pins in them, but you can see that it's not a solid pin. There's a little split. They're split right down the middle here. I went through every one of these with a small flat blade screwdriver, and just spread them out a little bit. The thinking behind this is that maybe I've got some oxidation build up between this pin and the mating contact on the cable side connector, and that by spreading these out a little bit, it'll abrade away some of that oxidation and make a better electrical connection. I'm also looking at the other side of the cable to see if the wires are crimped securely as well. I don't want any vibration to create these intermittent open circuits. So there. Did that for every one of the connectors, and as you can see here, this 15-pole connector here, I've been in there with the screwdriver and spread all those a little bit as well. You gotta be careful. If you spread them too far, what will happen when you try to mate them, they'll actually bend, and you don't want that to happen. Then you have to replace the connector. All right, I'm gonna change views here for a second. Hey, Susie Q.
What are you doing?
I'm doing a video on this battery
Putting back together.
control center so that someone else can benefit from what I learned.
Oh.
So how was work? We'll talk about that, huh? Maybe over wine. Okay, so I'm going to remove the printed circuit board from this assembly. First thing I have to do is this house feed wire is attached to this circuit breaker, and it's coming through the chassis of this box here. I need to disconnect this. I need to back this up here, so I've got a wrench backing up the head of this bolt, and loosen this. Make sure you keep track of what you're removing here, because this has to be isolated or insulated from the metal box. So I'm going to take this off, set it down here like this. This has to go back in that order. Now, when I pull this out, you can see here that there is there are two parts here as well. Or I'm sorry, no, there's not. There's one part here. This is a kind of a shoulder washer. It has a shoulder and then a large washer, and these are made of plastic, so this insulates or isolates the metal bolt from this side of the chassis, while this piece isolates the retaining nut from the chassis as well on this side. All right, so that's loose. We're good to go there. The other thing I'm going to take loose is there is a chassis power feed wire coming here to P14. I'm going to take that loose as well. This goes down to the interconnect solenoid. Oh, I'm sorry, this goes down to the chassis bus. Okay. So now we're ready to remove some hardware. Go ahead and take these bolts free. Let's see, let me move this over here a little bit so you can see better. There's one. Two. That just disconnected the coach solenoid from the back side of the circuit board. This is the chassis battery connection to the circuit board. The rest of the hardware, retaining hardware, is Phillips head screws, so we have two here. These two screws are the control contacts that control the direction that the coach battery switches. And again, the control voltage for these two terminals comes from the rocker switch inside the RV that engages and disengages the coach battery. These two connections are the control terminals for the chassis solenoid, the chassis disconnect solenoid. These two control terminals go back to the same type of rocker switch inside the RV that engages and disengages the chassis battery. And over here we have another screw, and this is coupling the ground connection. There's a ground connection down here on the side that goes to the chassis of the RV. That chassis is also referenced or tied right here onto this printed circuit board. At this point, we can just lift this board right up and out of there. And the only thing we have left now is there are two control wires that go down to the interconnect solenoid. We have to remove those. And I think those are actually smaller. Maybe a 3/8. Yes. Disconnect these two. As you can see, I've marked on this solenoid which wires go where. It really doesn't matter. This is a DC device that will magnetize the armature regardless of the polarity here. So, but I like to keep things standardized. So there we go. Now this board pulls out of there like that. So I'm going to set the board aside. Now, looking down inside this compartment here, it's pretty easy to see what we have. We have 3 solenoids. Battery interconnect solenoid. You can see here that when we apply 12 volts across these terminals, this contactor pulls in and ties. We're going to look at this right now. We have a chassis battery connection. We have a switched chassis battery connection. Then we have a coach battery connection. All right. If you notice, the coach battery connection and the chassis battery connection are tied to these aluminum strips here, these aluminum bus bars, and they're tied to either side of this interconnect solenoid. So when this solenoid engages, it's basically putting a short circuit across these 2 buses. This is what allows for auxiliary starting using the coach battery. It also allows for recharging of the coach battery from the engine alternator. So that's where this is controlled. There's actually a circuit on this printed circuit board. This area right in here is all of the logic and analog control that determines when this solenoid should engage and when it should disengage. And that's all based on the battery voltage levels. And there's a good description of that in the RV Custom Products user manual for this particular device. And I'm going to post a link to that on this channel or on this video. Okay, then you can see also attached to the chassis battery bus down here is this chassis reference wire that goes to the P14 connection on the printed circuit board. That's to get chassis voltage up there. I forget exactly what that's used for, but I'm sure there's a great reason that it's there. So you'll also notice that there is a solenoid here. This solenoid picks up the coach battery bus on this terminal. And when this solenoid is polarized in one direction, it will engage. It'll short the this terminal, which is the coach battery positive, to the switch side of this solenoid. And then this gets applied to the switched copper on this printed circuit board, providing voltage to these fuses here and to this particular circuit breaker here. Again, the fuses are all identified on the panel right there. I don't know if you can see that or not. It's probably a little difficult, but if you own one of these, you can look at it. Again, this is a bidirectional latching solenoid. So when I put 12 volts across this with positive here and negative here, this solenoid will engage, or vice versa. I don't know exactly the polarities, but if you swap the polarity, then the solenoid will disengage. Then you can remove the voltage and it stays in whatever state it was last in. Same thing for this particular solenoid. This solenoid is the chassis battery solenoid. There's a chassis battery bus down here. That piece of aluminum is attached right here to the input side of this particular contactor or latching solenoid. When you polarize it so that it engages, it ties the chassis battery to this terminal here, which also is tied by this red wire out to this particular lug, and this lug is called chassis switched. So it's the chassis battery that has been switched through the latching solenoid. Okay. This is also tied to J9 on the printed circuit board, providing power for various fuses here as well. Then, of course, down here, this is that ground wire that we saw earlier. The ground that comes into the side here is carried by a wire to the bottom of the standoff, and this standoff here goes to this pad on the circuit board, providing a ground connection to the circuit board. So that's pretty much this box in a nutshell on the inside. I'm going to go ahead and put this back together. So I will start off by putting my yellow wire and my red wire back. Be really careful when you put these nuts on here. They do have integrated locking washers, star washers, and that's just to provide a very positive electrical connection, but it's also to keep the nuts from backing off from vibration. You want to make sure that you don't over torque these, because you can damage the electronics or the electrical connections inside the solenoid. Ideally, you'd want to put a backup wrench on the nut below, but if you're careful enough, you can. I usually hold the lug, the terminal lug back, and tighten this just until I can feel that that star washer has compressed completely. I do the same thing with this one. Do not be a gorilla and overpower these things. Okay, good and tight there. The lock washer will hold it in place. Okay, those are the only two connections you have to make before you can place the board back in. Make sure to guide this terminal lug through the chassis. Okay. At this point, since everything's kind of loose and movable here, I'm going to go ahead and get my Phillips screws started. I'm not going to tighten those. I'm just going to get them started so that it kind of holds things in the proper orientation. All right, since I've got all the screws in on the top side, I'm going to go ahead and tighten this. Okay. These, you can crank them down pretty good because there are no lock washers on these. So go ahead and tighten them down really well. Okay, those are the 3 bolts. I'm now going to go to the screws. All right. It's very tight there. This is the chassis battery feed. Goes to P14. Make sure that's in place. The next thing we're going to do is make sure that the plastic insulator is coming through this hole. Then take the plastic washer. It should go around the shoulder of that inside bushing, and then start this bolt down like that. Oops, I think this one I had to use the 7/16. Now, you want to be careful because here's where you need a backup on the opposite side. You don't want to just start cranking on this. This has a star washer right here. You don't have to make this so tight that you crack through this insulating material here. The star washer will keep things locked. You're good, okay? So that's the complete reassemble of this unit. I can point out a few things here, I guess. Okay, this particular connector here, this is the P1 connector. The P1 connector has your auxiliary start switch. The auxiliary start switch comes into this interconnect relay control circuit here, and it forces this to engage so that you can use the coach battery to assist the chassis battery to start the vehicle. That's on here. You also have a radio feed on here. You have an antenna booster connection here. The radio memory is here as well. Then on the P2 connector, down below it here is a little 6-pole connector. And these, by the way, are all keyed. There are some blank holes in here that it allows you to have the same number of positions on a connector without getting them reversed. So if I wanted to put P3 where P5 is, I couldn't because the keys or the the blanks are in different locations and they will not allow me to connect it. All right, so anyway, the P2 connector has a solar panel connection, which I do not have. It has outside radio memory, outside radio control. It has cargo light, 2 different cargo light connections on it, okay? The P3 connector over here. The P3 connector has the voltage for the steps and the awning. It has fog light output on it. The stepper motor, or I should say the step motor for the steps is here. The step motor feed to the step motor, or the step switch is here as well. And you have dock lights and driver's seat if you have power seats, and I don't have that. Then on the P4 connector, which should be right here, this P4 connector has the driver's shade, which I don't really have a power shade on my RV, so that's a spare. It has a passenger shade, which we don't have either. Then there's map lights. We have PowerPoint. I'm not exactly sure what that is. Then there is the light relay, fog light relay in here that controls the fog light. So the fog light command is given here. The relay energizes and outputs power to the fog lights through this J3 connector or P3 connector. P5 over here. Okay, P5 has on it the accessory relay control. So when your key is on or in the accessory position, it will energize the accessory relay. Then over here is HVAC blower control, dash fans, mirror heat, jack power, and the motorized mirrors are all on this connector. Finally, the P6 connector over here, and I hope you can still see this, has a spare at pin 1, and it also has a jacks down. By the way, this is fed by the ignition relay here. So, so there's a spare, there's a jacks down line here. There's TV cutoff control here. There's also a rear vision feed for your rear view cameras. And then there's the command in here to actually energize this particular ignition relay right here. Okay, when you turn your switch on or when it's in the run position, there's 12 volts there, or ground, one of the two, I forget which. But anyway, it does energize this relay. I believe it's 12 volts because this relay has a common ground connection. So there you are, in a nutshell. Again, all this information will be in the link I put on the bottom of the video, okay? All right, the next step is double check everything. I'm gonna make sure now that this guy is ready to go back into the RV. I'm gonna put it in and see how things perform. So just to let you know that every now and then you got to take time out. I was right in the middle of this video when Susie came home, and she told me earlier she was having a bad day. She texted me. She said, man, it was a crazy day at work. And so I really didn't want to stop doing this video, but that was my clue right there that I need to take time out and get with my wife, give her some time, let her vent, let her talk, pour her some wine, and poured myself some wine while I was at it. The decisions you make are important, and I'm not good at this. I'm not bragging. It's just that I'm trying to be more conscious of the needs of people close to me, as well as people not so close to me. And sometimes it strikes you as inconvenient. You know, you're in the middle of a good TV show, or you're watching the news, or you're enjoying a great meal, or you're in the middle of a project like I was doing here, and it really pays. There's a payoff to stopping what you're doing, moving beyond yourself, and being kind to somebody who really needs a little bit of kindness. And that's what Susie needed today, and I need it every day, honestly. So you people are kind, you people are nice, you're generous. I don't want to babble here because I know that that's not why you really come here, but I'm reminding myself, I guess, documenting this right here so that in the future I can look at this and say, you remember when you said that? Are you still doing it? Do you mean it? It kind of is like, it kind of reminds me of something someone told me a long time ago, that true character is what you are when nobody's watching you. So Am I just this way when I'm on the camera, or is this my lifestyle on and off the camera? So anyway, friends, I'm gonna put a few more things together here. I might show this thing going back into the RV and giving it a test. Dang, there's so much I wanted to show you on this. Really, there's a lot of troubleshooting you can do. I took all these relays that are in here. I applied 12 volts to them individually, make sure they were clicking, make sure the solenoids were moving the right direction. Did all of that stuff just to make sure things were working right on that board. That's all stuff that's very easy to do, honestly. I mean, you need a power supply. You need 12-volt battery that you can just set on your bench and connect some wires to it and use that as a power source. But you can test a lot of things out on this. And so we're gonna see how it works. I'm gonna put it back in the RV, wire it up, and get the show on the road. All right, I may talk to you later. So before you put this battery control center back into the RV, make sure that your battery positive terminal is disconnected on your chassis side, and make sure that the coach positive terminal is disconnected. And that way you're guaranteed not to short anything out over here. I've got all my wires bundled together here that go to these outside terminals. They're all right here. And the other connectors are down below, right here. The J1 through J5 and J15 connectors, they're all right here. So it's going to be good to get those out of the way as much as possible when you put this in. So move them off to the side. Use wire ties if you have to. These backwards are really difficult. Everything's blind. You cannot see what you're doing. And you do have to be a contortionist. Oh yeah, there we go. Yeah, she's going. Yeah, there we go, we're in. We're in, and we're just about as tight as we want it to be here. Oh, let me get a little bit of help. Oh yeah, there we go. Now the bottom one, get it tight. It's in, but it's just, it's not tight. There we go. Those are the two hardest ones right there. Two hardest ones. Now let's get this one over here. Finish. There we go. It's in, folks. It's in. It's really in. Okay. Now. So I'm going to cut these apart. I've got them tied together with a wire tie. There should be 5 wires here. I have them labeled. I have coach battery here. This is house panel here. This is the ground here. This is my chassis switched terminal, and this is chassis battery here, going all the way to the chassis battery over there. Okay. Panel back on. There we go. To just go ahead and take this to an RV dealer and have a professional do it. I am not a professional, so if you want this to work out well, unless you are like pretty tech savvy with this kind of stuff, I wouldn't attempt it. I would take it to a professional and have them do it. I'm just documenting this. It's for my own good, so I can look back on it in the future. And I'm putting it out there just so other RV owners know, who have the same kind of electronics, that there is information out there on how the stuff works and how it's put together. Again, I will put links as I get them here. I'll put them in the video, so you'll have them. I'm going to go ahead and finish hooking the batteries up right now. I'm going to start this thing up, make sure everything's running okay, and check back with you. Okay, we got her working. So everything's together. And here I got the coach battery and the chassis battery connected. Started right up. Everything's looking good so far. I'm going to check out the fans. It's really getting dark out, folks. Let's turn on the coach. Get some lights in here. What I want to see is, do my fans work? Let me turn my map light on. So, let's see. The switch for my fan is here. Fan's working. That's a good thing. The next thing I want to see is whether or not my mirror is working. I go ahead and hit left. Oh yeah. There it goes. Up and down. Nice. Feel pretty good about that. Okay, well, I think that's it, folks. That's all I have. This is really kind of an interesting project to me. This is the kind of stuff I love doing. So RV's working fine. Time to edit some video. See you, folks. Be kind. Love one another. Okay? See ya.